Good afternoon. So we'll be discussing MongoDB right now. So what is MongoDB? It's a NoSQL document-oriented database designed for high scalability and flexibility. It stores data in JSON-like or BSON formats rather than traditional relational tables. It is ideal for handling unstructured and semi-structured data. Why should one use MongoDB? It is scalable. It has flexible schema because it does not have predefined schemas. It uses horizontal scaling like sharding. It has high performance read writes. It has cross-platform compatibility, so it's used in different operating systems like Windows, Linux, Mac OS, and even cloud environments. It's developer friendly because it works with modern application frameworks. It has a distributed system, schemaless architecture, multi-model support, multi-cloud deployment, and open source and enterprise options. The core components of MongoDB include the following. It has a database, which is a container for collections. The collections are a group of related documents that are similar to tables in SQL. The documents have individual records like that are stored in BSON object formats. It has fields called as key value pairs that are inside the document. It has replica sets which provide automatic failover and high availability. It has sharding which distributes large data sets across multiple servers. It indexes and improves query performance by enabling fast lookups. It has aggregation frameworks which perform complex queries and data transformations. It has a compass and atlas, which a compass is a GUI tool for database visualization, and a MongoDB Atlas is a fully managed cloud service for MongoDB. The key features of MongoDB include the following. It has no fixed schema and documents can have different structures. So it can very well be used in resume parsing projects like mine because it has schema flexibility. It has high scalability and high availability because it uses sharding. It uses indexing for performance, so it uses B-tree indexes. It has ACID transactions, which ensures atomicity, consistency, isolation, and durability. It uses geospatial capabilities, which support location-based queries. It has text search features, which optimize full text search functionality in all applications. It has multi-document transactions, replication and data redundancy, and aggregation pipelines, which enable complex data analytics within the database. It has time series data support, which is optimized for IoT and event-driven applications. The installation of MongoDB can be done by the following. The, the first step is to install MongoDB Atlas or the self-hosted edition, the community version. Then it's basically compatible with all operating systems, so it can be downloaded from the official MongoDB website. The users can use package managers like Brew or apt-get for different operating systems. Then MongoDB instances can be configured using the mongodb.configure, and MongoDB shell can be used for command line interactions. Then the next steps are basically similar to any other database. Basically, create a new database, enable authentication, and use MongoDB Compass or Atlas, depending on different graphical or easy orchestration containers. The CRUD operations in MongoDB include the following. The four primary operations include create, read, update, and delete. These have different syntaxes. So create db.users.insert1 helps users insert different data fields for different columns. Read basically helps users read the data. Update helps users update data in a particular column field, and delete helps users delete data from a particular field or column. Other operations include bulk insert, find with projections, sorting, limit results, and count documents. All of these are used in different applications. For example, bulk insert helps users insert multiple columns. Sorting data helps users sort based on different criteria. For example, age-wise. Limit results helps users limit results based on findings. And drop collection and count documents. basically help users drop fields or even count documents in the MongoDB database respectively. Why indexing matters in MongoDB is because it speeds up queries. It uses B-tree indexing. It has single field index and compound index, which basically uses multiple fields. And it also has text indexes, which is optimized for text search. It's also used for hashed indexing and wildcard indexing, which supports dynamic schema structures. And it's used for performance monitoring and avoiding overlooking because too many indexes may slow down the writes. Advantages of MongoDB include the following. It does not have predefined schemas, so it has schema flexibility. It has something called as sharding, which expands across multiple servers. It has high read-write performances, and it has rich query languages, which supports aggregation, geospatial queries, for example, in MongoDB clouds and text search. It's also used for strong cloud integration because it works well with different applications like AWS, Azure, and even Google Cloud. It has multi-model capabilities because it supports document graph and even key value models. It does not have complex joins that which basically reduces the need for foreign keys. It is ideal for big data and IoT applications and also for auto sharding, which distributes data across clusters seamlessly. It supports asset transactions for financial applications. Disadvantages of MongoDB include the following. It has high memory usage because it stores indexes and documents in RAM, which is unfortunate because it cannot be used in very large systems. And it requires, if so, it requires higher storage costs. It has limited transaction support and lack of joins, potential write conflicts as well. Therefore, it needs careful handling in high write environments. It does not have built-in storage stored procedures, so it requires application level processing in many applications. It has complex backup strategies which require periodic snapshots for point-in-time recovery, and it has limited SQL support. It also has a steep learning curve which requires understanding of new SQL design patterns. A comparison of MongoDB and SQL databases shows the following based on different features. MongoDB has document-oriented data model, whereas SQL has a table-based one. MongoDB uses a flexible schema, whereas SQL has a fixed one. And it has a horizontal limited asset support and optimized for read-write applications, whereas SQL has a vertical scalable structure. It has complete asset compliance and it's optimized for complex queries. MongoDB is usually used in big data applications, whereas SQL is used for structured and complex relationships. MongoDB aggregation framework basically is a way to process and transform data in MongoDB, and it has multiple stages to filter, transform, and analyze data. So these are some of the different kinds of commands that can be used in pipelining. Match stage filters documents based on condition. Group stage groups documents. Project stage reshapes documents, and sort stage orders documents based on specific field, and so on and so forth. All of these can be used in analyzing customer purchases for business rights or in business models to analyze stocks and purchase models for a certain product. Sharding in MongoDB splits large datasets across multiple servers. There's something called as a shard key, which is a field used to distribute documents across shards. This has a configuration server which stores metadata about shard distribution. It has query router, which is also called as Mongoose. These direct queries to the correct shard. These have different kinds of shardings like range-based, hash-based, and zone-based sharding based on the different applications that are needed. And the best practices for using this is to use an effective shard key to prevent bottlenecks. Replica sets in MongoDB are a set of MongoDB servers that maintain copies of the same data. They have primary nodes that handle all data read writes by default, secondary nodes that maintain copies of data, and automatic failover. If the primary fails, the secondary is promoted. It has operation log, which stores changes made on the primary key, and arbiter node, which helps in elections but does not store data. The best practice for this is to deploy at least 3 nodes for fault tolerance. Some of the security practices that are used by MongoDB are that it enables authentication, it encrypts data in transit and at rest, it has strong passwords and limits network exposure using something called as IP whitelisting. It has enable audit logs. It disables JavaScript execution and implements firewalls. It also has VPC peering, which isolates MongoDB instances within a private network, and it monitors logs and alerts using MongoDB Atlas monitoring. Some of the real-world use cases for MongoDB include the following: e-commerce, basically for product catalogs and shopping carts; social media, IoT and sensor data; healthcare, finance, and gaming. It's also used in content management, log and event processing, and even customer analytics. MongoDB Atlas is a service which is a fully managed service that handles backup, scaling, and security. It is a multi-cloud deployment model which is available in AWS, Azure, and GCP as well. It has automated backups which ensures data protection and global clusters that replicates data across different regions. It has built-in security features like encryption, access control, and even real-time monitoring. It is a serverless option, so you only pay for what you use, and that's efficient for smaller businesses. It has easy scalability and data federation for querying across multiple data sources. Performance optimization in MongoDB uses indexes efficiently. It optimizes query design and sharding for larger data sets, basically distributing the workload. It reads preference settings, balancing read-write operations effectively. It has connection pooling, which improves database connection handling. And it also has pre-aggregation and TTL indexes, which automatically remove old data, making it efficient for data storage and compliance. Some of the future trends in MongoDB include the following. It can be used in AIML integration platforms, in graph database capabilities, and also in serverless MongoDB applications where fully automated resource allocation platforms occur. It can be used in advanced security features like stronger compliance integrations and hybrid cloud support. It's also used in enhanced query optimization for AI-powered query tuning and also in ETL data pipelines for easier integration with BI tools. Some case studies for MongoDB include the following. Netflix, which stores user recommendations and watch history. Uber tracks trips and geospatial analysis. Forbes has real-time content management. Adobe uses cloud-based document storage using MongoDB. Cisco has network security and monitoring, and it combines and integrates these functions with MongoDB. And also, Capital One has credit card transaction processing, which is also integrated and complied with MongoDB. Best practices for these include monitor performance, use using indexes and optimizing the schema design by reducing the duplication values. Also limiting field projections and avoiding oversharding can be an effective way to make MongoDB a more efficient platform to use by using an effective shard key. Also, backing up data regularly prevents data loss, and using aggregation pipelines effectively avoids complex transformations. All in all, MongoDB is a powerful, high-performance NoSQL database. It can be used for many modern applications. It's best for big data, web apps, and IoT applications due to its flexible schema, no schema architecture, and very fast read-write capabilities. It's preferable for highly relational data models with strong asset compliances, and it can also be integrated with strong cloud and multi-platform support systems, making it very effective for developers to build scalable applications effectively. Thank you.